Today is Azure AI and Machine Learning for everyone. And welcome to our webinar. My name is Jasmine, and I am very happy to be your host for today. This is a quick disclaimer. Microsoft Teams deliver a rich interactive experience, so we encourage downloading the app if you do not have it, as not all browsers are supported. Also, another note is that you will be prompted to choose if you like to join anonymously or join through a registered account when you click on the register button. When you join this event, your name and email may be viewable by other session participants in the attendee list. By joining this event, you are agreeing to this experience. If you'd like to read more about the privacy statement, we also have the link here for your information. So welcome to our second webinar. This webinar is a part of our Microsoft Azure Virtual Hackathon, which is happening right now. And we are still open to receiving your ideas and submission until May 17. So why not grab your friends and join our competitions? You can further check it out in msazurevirtualhackathon.com. Let me walk you through the webinar agenda for today. So first, we will have the presentation by our speaker from Microsoft, Ian and Sudhir. And then after that, we will have time for Q&A to answer your questions about Microsoft Azure, AI, machine learning, as well as about the competition. Last but not least, please stay tuned for our mini games. We do have a lot of swag to give out to you for the one who is paying attention and fast enough to join our mini games. So we really hope you can stay tuned with us and stay along for this webinar today. Thank you so much for your time and attention. So without further ado, let me introduce you to our Microsoft team who will share with us about Azure AI and machine learning for everyone for today. So first we have Ian Choi. He's a developer relations from Korea, based in Seoul, and also from the Microsoft team. And the second speaker is Sudhir, the developer product marketing manager, also from Microsoft. He's based in New Zealand. So with that, I would like to invite Ian to kick off our webinar today. Hello, Ian.
Hello, Jasmine.
Wonderful.
Hello. Yeah, my name is Ian, and today I would like to start first on Azure AI part, and also Sudhir will explain Azure machine learning for everyone with great demonstration. We are working in the same team. Someone says us as developer PMM, each internal official our job role, but we are working for developer relations. So sometimes then we say as developer product marketing manager or developer relations team. So please understand such details. And so today then I would like to start by introducing Azure AI, and the next time then Sudhir will explain data science lifecycle with great demonstration on Azure on machine learning. After then I will be back to explain, to share some tips for our hackathon activities. Okay, then first, let's start with some breakthrough research on Azure AI. For research perspective, and then Microsoft has been doing a lot, but I'm not sure whether you all recognize well or not. So I want to start that Microsoft is investing a lot also on research area across the spectrum of all AI research area. So yeah, for example, then there were some ImageNet contest previously, and then so many companies, for example, not only Google, but also Microsoft participated in competition for image test. And then when I remember for Microsoft, it might be 2012 or 13, and then Microsoft won the first with a great algorithm on ImageNet. After then, although then Google won in 2015, as far as I remember, but many vendors are competing each other. So with such great research, and then Microsoft AI, Azure AI has been evolving a lot. It all starts actually with big breakthrough research. And then I want to take a few examples of some research. In Microsoft, and then there are many MSR. MSR is Microsoft Research. The center of MSR is located in Redmond, but I've been some university graduate students who previously went to MSR Redmond or MSR Beijing. So they are researching a lot, and they are publishing many great publications on SIGCOMM or any other machine learning algorithms and so on. So then they are researching a lot to give more energies on Microsoft research AI research. Thanks to such kind of research activities, and then now Microsoft AI shows a lot on great performance from Microsoft products themselves first. For example, then I'm not sure whether you all are using Bing or not. So that now there are many great also such websites, but Bing is evolving a lot, and still then Bing is part of one of great such websites. And then Bing has great performance on search. So Bing has AI, great Azure machine learning powers, over 280,000 AI insight recommendations daily to advertisers. And for cognitive services delivers over 6 million personalized experiences on Xbox daily. So with such kind of great things, and then such great things have been reflected into Azure AI. So thanks to this, and Azure AI boosts the productivity of developers and data scientists and empower them to build AI solutions much faster and faster. Also, then Azure AI enables those AI solutions to be deployed at scale alongside existing systems and processes. So thanks to this, and then Azure AI will ensure organizations can build with full confidence, knowing that they know their own control on AI privacy issues for control issues, using their data on their platform or on the top of cloud, so that they deal with lots of compliance issues and also great performance. So these guiding principles enable us to fulfill our mission, Microsoft mission. Microsoft mission is to empower every developer and every organization to harness the potential of many things, including AI. To divide into Azure AI, and then Azure AI can be divided into three different areas. One is for AI apps and agents, and the second one is knowledge mining, and third one is machine learning. Then today, then I would like to cover the first and second one part, and the third one will be explained by Sudhir. But third one is still very nice. I will mainly talk about some AI stuffs using pre-built AI developed by Microsoft, but also that you can develop your own algorithms with your own great machine learning algorithms. So Sudhir will explain the later part. Okay, then let's start from AI apps and agents. So to build breakthrough applications, Microsoft offers a comprehensive set of pre-built models with cognitive services and comprehensive bot building platform with bot services. But today, then I would like to more focus on Azure Cognitive Services because then both service is mainly target for conversational AIs. But for this, our Azure AI Hackathon, and then we focuses mainly on graph challenges and also UNDP challenges. Then I think those challenges are more related with Azure Cognitive Services rather than Azure Both Services. For Azure Cognitive Services, this is a core part of AI to create technology that can help machines mimic human ability to perceive the world around us. So it does not just not refer to just computer visions, but also then lots of other things such as language, speech, and also search research. So those kind of, if you think about some perspective leveraging those language data, vision data, or speech data, or even web search data, then it is very good idea to integrate with Azure Cognitive Services. Cognitive Services offers pre-built APIs, so you can just integrate very easily using visions, also languages, and integrate in these into your applications to deliver immersive user experiences. Also, the web searches brings great human knowledge. So then, in my opinion, then if you leverage previous existing data, for example, graph challenges using GPS data, then if you want to integrate with other human knowledge using on the web, and then you can easily integrate with web search APIs. So, and also then there are another category, decision. This decision category goes a step further than observing the world using speech, language, and vision. Services in this category provide users recommendations to enable informed and efficient decision making. So after you train using your own data or provided data, and then you infer something, and the goodness of AI is to how to integrate with your own decision or your preferred decision to make change the world more nice. So in that case, and the decision category really helps. And then, so now then I want to introduce personalizer. Using personalizer, then you can easily embed powerful personalization capabilities in your apps with a simple API. This product is already powering personalized content, serving to Xbox users, driving significant upside. So we want also continue to bring new services in other categories, but I'm not very sure whether currently then I don't have enough idea to integrate, for example, ink recognizer, which recognize your type words, and then it can be, for example, BUILD, it can be recognized as BUILD, English characters. But if we have some great idea to integrate with some handwrite typing, then ink recognizer would be great. And also in speech, and it is related with conversational transcription capability. So then if we want to integrate with your voices to convert from speech to text, or if you convert from text to speeches, and then using speech API would be great. So those total sets are for Azure Cognitive Services. So with these cognitive services, then you can implement using great set of capabilities across speech, vision, language, web search, and now decision for you to use. So then today, then I want to show some videos on personalizer in action. Because then this personalizer is already integrated into Xbox. Xbox is also one of Microsoft's great products for gaming area. So personalization is actually a kind of complex problem. So then if you think about such personalization perspective into your own challenges, and then it'll be great. And those behaviors is affected by actually many factors. So for Xbox users, this could include not only data, but about the user, but also the context, the like day of week and friends online, So gaming requires more interactions to capture more interactions. Uh, if it's hard problem for one, then it will be very hard to solve some how to better provide personalization things. So it can be also related with some reinforcement learnings or there's some other more functionalities, what users can experience using Xboxes. So putting on those into data scientists, and a typical AI approach would look those data and then how to deal with data like this. But please think about, I want to emphasize that, please think about the overall architectural issues, how to convert such daily of work into recurring activities by days or weeks or months. So such factors would be related with some architectural decisions. So there are for this Azure AI Hackathon, and then it'll be nice if you consider how to convert your great idea into architecture, your own preferred architecture, which can be solved using this production. So thanks to this, the Xbox improved lots of personalization activities, and so Xbox get more than 40% of lift in user engagement. This is one of the examples using Xbox, but it'd be nice if you think of personalization things stops in to integrate with your own challenges. That is my first saying. And the second saying is that it'll be also great if you think about not only your problems and how to solve your problems, but also then think about what would be feasible architectures to really work in production. Okay, of course, and then we continue to make it easier for you to run cognitive services anywhere from the cloud to the edge. So there can be lots of things, but so the thing I want to mention is that please think about how for previous APIs and AIs, then you can just integrate with APIs, but also then still some productions perspective would be missing. So please think about how you convert just not using just leveraging cloud AI APIs, but also then please think about how to convert your own idea into real feasible architecture. And second part I want to explain is knowledge mining. And knowledge mining is just not just knowledge mining itself is to find some insight from lots of scattered or unstructured data. For example, like forms, PDFs, or contracts or images. Most of those data are rather unstructured. So with knowledge mining, then you can leverage industry-leading API capabilities from Microsoft to easily unlock some latest or latent insights from all of scattered content or unstructured content in scale. So then please think about that. What if we could extract all this rich information using AI? In that case, and then knowledge mining with Azure Search could help to uncover insights. Okay, then let's think about such overall steps. So ingest would be to capture raw data to convert from unstructured to structured, which computers can read and identifiable. After then it needs to be converted into some meaningful information to extract the keywords, for example, keywords from the statement or some detailed context from your face or some overall structure of this document or the key phrase identification or some location information or and so on. After then, it'll be converted into like very structured data, which can be really used to analyze with some other components or then to integrate with other existing computer programs. With just a few samples, that it tells us its understanding to supply documents. So for example, those data could be captured and then it can be analyzed into two structure into actual JSON or some more structured information into database so that it can be really used in with existing applications. With such perspective, and then please think about how you try to convert some existing or real-world unstructured data or scattered data into structured data. So such concepts would be also useful to apply into your own AI challenges from Grab or UNDP. Okay, yeah, that's my general introduction on Azure AI, especially emphasizing on pre-built AI. And from now, and for machine learning, then Sudhir will start.
Cool, thanks, Ian. All right, so hi guys, my name is Sudhir. I work as a Azure Developer Product Marketing Manager based out in New Zealand. And as my colleague mentioned earlier, we are here to talk about AI and machine learning for everyone. Now, in today's world, if you go to any organizations or maybe any communities, or maybe, if you look all the attendees who joins today, they may be working on a different platform while they're building the machine learning solution, right? Now, Microsoft basically, try to provide all the tools and the framework so that every person in the organization, can leverage Azure to do more in their job role. That means we don't want to enforce any new tools or technologies which you have to learn again and again, right? So today, if you're, let's say, working on Python and you're using scikit-learn languages, you don't want to go to TensorFlow or maybe you don't want to go any other algorithms. What you want to leverage your existing skills so that you can continue building great products for your customers or maybe for this planet, right? And that's where the Azure machine learnings come into the picture. On the top, we have some pre-trained models, which comes under the part of the Azure Cognitive Services, which my colleague already discussed about, right? Now we have various familiar data science tools. So if you're familiar with working on Jupyter notebooks or you're familiar or want to have your own environment rather than installing any dependency on your systems, you can actually go ahead and go for the Azure notebooks. Or maybe you can leverage, build and deploy your machine learning models. We cover various popular framework to build advanced deep learning solutions. So either you're working on PyTorch, TensorFlow, scikit-learn, or ONNX, which basically provides you to build the models which you can deploy on the cross platforms. You can actually go ahead and leverage in Azure. We also have some productive services. That means we don't want you to, more focus on the infrastructure side of it, or maybe installing the libraries, configuring those libraries, setting up the packages, and so on and so forth. That's where the Azure machine learning, the Databricks, and the machine learning VMs come into the picture, right? We'll more talk about the Azure machine learning features, but machine learning VMs, it's a pre-configured VMs which has all the packages installed and configured in it. So as a data scientist, you don't need to focus on installing all the environments on your VMs. What you can do is you can just spin up a machine learning VMs and you will get all your environment set up over there. And then you can actually go ahead and start working from the day one. Behind the scenes, train or retrain your models. We provide various compute systems which basically accelerate your deep learning model. So either you're targeting the CPU, GPU, or FFGA kind of on a hardware, we cover everything. I mean, we have all different types of compute services available, which you can leverage to train your models in no time, right? Now all these are in cloud, so that's what we say intelligent cloud, and as well as we understand and we know there are some decisions that you want to take on the edge, maybe because of the latency, though the latency from your devices to the cloud is going to be in a millisecond. But in certain scenario, those millisecond latency could be very heavy, right? Hence, you want to do these decisions making onto the edge itself, right? So that's where we also have the capabilities to bring down some of these machine learning or the AI capabilities on the edge, so that you can actually do the processing then and there and take a decisions on the edge itself. So let's go ahead and talk about a little bit in details on Azure Machine Learning. So I'm not sure how many of you worked with the Machine Learning Studio earlier, or maybe Machine Learning, the Workbench services, which is kind of an old. But now Microsoft Azure has a machine learning services, and it has basically 3 features in it, right? So one is the automated machine learning UI. We'll talk about more in details because it's a very interesting concept that we bring, which basically helps data scientists to reduce their jobs or reduce their efforts to keep retraining the models until they achieve, let's say, certain accuracy that they're looking for. Then we have the visual interface. So if you're new or if you're not sure about it, how to write a code in the notebooks. So what you can do is you can use this visual interface, and then you can drag and drop your models, bring your data sets, and you can just go ahead and deploy your models. So all through the UI, you don't have to write a single line of code over here, right? And then obviously, if you're a very advanced user, you work with your notebooks and love your notebooks, we also have that capability. So machine learning services has all these 3 capabilities in it, which helps you to design your machine learning models. Okay, so let's go ahead and move on to the next. Yeah, so the other thing is you might be knowing the data science lifecycle, right? So that's where the DevOps or the machine learning ops comes into the picture. So if you do a comparison in the DevOps environment, traditional software developments, we have this code reproducibility, code testing, and app deployment. That means as soon as any changes that you have made to your software, it basically goes through the various testing environment that you have set up, and then everything's correct. You probably send a notification to the team leader or the team managers, and once they sign off, the app goes to your production environment. So everything is automated, and it's not a different case when it comes to the machine learning, right? I mean, you have your model which you want to reproduce. You want to make sure for the validation of a model, then you want to deploy your models, and at the end, you want to actually want to retrain your model as well. So that's kind of a difference between an app developer who are using Azure DevOps as compared to the data scientists who are using the machine learning. So what you do is you basically collaborate, and then we're gonna look the data scientist journey, where you actually train your model. You basically bring your data, you do feature engineering, and then you train your models, and then you validate your model. Based on the business requirement, based on the accuracy, maybe based on the RMSE loss, right? And then at the end, you basically deploy your machine learning models, maybe onto the Azure or maybe in the Kubernetes cluster, depending on your business requirements. And then over the period of time, you basically monitors your model, right? And then you probably want to retrain your model automatically, and then the cycle will keep going on, right? So we have the Azure DevOps, which basically helps you to make this happen. So that means as a data scientist, you don't have to do all these things manually. Once you check in or once you trigger, it automatically starts training your models, validates it, and deploy it into the productions, right? And you can actually go ahead and monitor everything. Now you have a different versions. DevOps will take care of maintaining the record of all the different versions that have been deployed, so that every point of time, if you want to roll back or you want to look into the audit, you should be able to look into that. Okay, before I move on to the next step, I'm just gonna give you a good understanding of what is AutoML is all about. So I'm just gonna go back over here and as an example. Okay, so I'm assuming you're able to, right now you're watching the machine learning problem example. And let me, okay. So let's take an example over here, right? So let's say we want to figure it out how much this car is going to cost me, right? Or what is the worth of this car, right? So as a data scientist, as a machine learning developer, what I'm going to do is I basically focus on three areas, right? So one is which features, which algorithm, and which parameters that I'm going to consider, right? So that means creating a model by taking all this into the consideration is a time consuming for me as a data scientist, right? So now as an example, here are my features, and then we have certain algorithms that I pointed out, and then we have certain parameters for each algorithm, right? So let's say we decide we're going to take these three features. We're going to decide, okay, let's go ahead and start with the gradient boosted algorithm. And then these are the parameters, right? So by applying these parameters with that algorithm and the features, I basically get a 30% accuracy with my model, right? Now, then what I do is as a data scientist, because 30% is not expected, I basically go ahead and change the algorithms, or maybe I change my hyperparameters, or maybe I change some of the features, and then I start retraining my model, right? And then it basically gives me, okay, your accuracy is 50%, right? Now, again, this 50% is not expected by my business. So then again, as a data scientist, I just go ahead and change some hyperparameters or algorithms or features. And then I basically gonna have a uh, long list of all the runs that I've made it happens based on the different features, algorithms, and parameters. And I got all these accuracy. And then I'll actually go ahead and pick a particular accuracy, which is the threshold for my model, right? Now think about how much time as a data scientist that I have to invest in it. It could goes for a days, it's gonna go for maybe weeks or months, right? Depending on how big data that we have and what kind of training parameters we are taking, how many algorithms we are taking, what are the combination that we are taking, right? So it can take a lot of time for me to come up with this particular model, right? And then maintaining all this in Excel or maybe in somewhere, it's going to be a time consuming and a painful job for you, right? Now that's where the automated and machine learning can help you, right? So it's basically allows you to automate your features, feature engineering algorithms and hyperparameter selections to find the best model for your data. So what you're gonna do is at the end of the day, you just go ahead and give the data and you basically tells what kind of a problem that you're dealing with that particular data, and then automatically the Azure automated machine learning will pick up different features, different algorithms, and different hyperparameters, and then it basically gonna run in parallel, right? So you can just leave it run, and then you can come back maybe in an hour or 2 hour, depending on how much time it's required based on what you're expecting from your model, and as well as how much compute power that you provided behind the scenes, right? And then it basically gives you the results back, right? So this is how it's gonna look like. So as I mentioned, as a user, you just put your data sets, and then it basically gonna look into your data, and it automatically is gonna select the algorithms and selects various hyperparameters to tune your model. And once it's done, it basically gives you a list of all the models that has come out from those combinations. And then you can actually go and pick up which model is best suited for your problem that you're trying to solve with automated machine learning. All right. So with that, let me just go ahead and show you how easy it is for you to do that in Azure Machine Learning framework. So I'm going to go back to my desktop and I'm going to go back to my portal, Azure portal. Okay. Jasmine, can you confirm me if you are able to view my Azure portal at this point of time?
Yes, I am seeing it.
Okay, cool. Thank you. All right. So creating a machine learning workspace is pretty easy. What you can do is you can go and say, I want to create a resource. You can click on that and say, I'm going to create a machine learning. And then you can actually go ahead and get this machine learning, click on create. And once you click on that, you basically provide your workspace name or your project name. You can say that, right? Provide your subscription, provide your resource group name, location where you want to provide, and then which workspace edition you want, basic or enterprise. So basic has may not have all the features that you require. So if you're building your machine learning model for enterprise, always recommended you go for the enterprise edition, right? Now I'm not going to get into that because I've already created one machine learning workspace, which is here. And then what I can do is, it basically asks me, you can actually go and launch the machine learning studio. So I'll click on that, which basically going to take me to the screen, right? And on the left hand side, you can see I have, when I go into the author option, I have three things, right? So one framework that we have is the notebooks, which we'll talk about. So if you go to the notebooks, you can actually go and create, start creating a new notebook file, and you can start writing your code in your notebook. So click on I can book. I can select whether it's a Python or not. So I'll just say Python notebook and just go ahead and create it. And as you can see, this is got created. And what I can do is when it gets loaded, I can actually go ahead and start writing my code. Now I'll just move on to the next. So the other option that we have a designer. So if you're new to the machine learning world, you can actually go ahead and get started with the designer. What that means is with the basic understanding of the machine learning lifecycle, you can actually go ahead and use the visual designer and you can build a machine learning model. So you can start with the data sets and then you have the various algorithms over here from regression, clustering, classification. And then you can, just go ahead and drag and drop into the UI interface over here, right? And then you can actually go ahead and train your model, score it, and evaluate, right? And once you publish that, it basically going to deploy this model and provide you the endpoints so that you can make a call, right? So that's another way. Now, what I'm interested in is to show you the automated ML that we talk about it, right? So if I go to the automated machine learning option and I'm going to say, hey, I'm going to run a new automated machine learning run. I'll click on that. And it basically asking me which data set that I want to involve over here, right? So I can say, okay, go ahead and create a new data set from my local file. Or maybe I can get it from web. So let's say data set 2, and then go into the next step. And I can go ahead and browse for the file. And I'll select my file and say next. You select Workspace and say next. So now what's going to happen is it's basically going to upload this CSV data onto my Workspace. And what this data set basically contains, it contains the information about our customers. And at the end, we have a column where it basically defines whether the customer is going to go for the fixed deposit option for the bank or not, right? Based on the various features that are presented in that CSV file. right? Now, once it gets uploaded, the data, I'll move on to the next step. And right now it's parsing my data set information, and I can say this has first row as a header. And now you can see this is my data set. I have age, job, educations, and all these features. And at the end, I have my target column, which is Y, and it has yes and no, only two options over here, right? So it basically defines whether the customer is going to be interested in the bank deposit or not, right? So just go ahead and click on next. Then it basically shows me all the schema. That means what all columns are available over here. So if I want not to include any of the columns, I can actually go ahead and turn it off and move on to the next step. And it says, okay, this is all you want. So just go ahead and click on create. And once I created a data set, I can go ahead and select that data set and move on to the next step. And here, what it's going to do is it's basically asking me, just go ahead and provide the experiment name. So I'm going to say this is my marketing event. What is the target column? So the column name Y was my target column. And then I can select a compute, because whenever I'm going to train my model, behind the scenes is require a compute, right? So if you don't have any compute where you want to train your machine learning model, you can click on the create new compute, and you can see we basically provides various kind of a machine, either GPU or CPU, depending on the subscription that you have. And then you can actually get and select your virtual machine size, which you feel is going to be the optimum to train your model, right? Now, I've already have one training cluster, which I'm going to use over here. Okay. Now, once I'm done with that, I'll just go ahead and click on next. And now you can see it automatically decided that this is going to be the classification problem, because I'm only interested in yes or no, right? But then the other option that you have is you can actually go ahead and use regression or a time series forecasting, right? Now, if you feel that the automatic selection is not the right one, instead of classification, you want to do regression, feel free to go ahead and select regression. Now, I'm not going to click on finish because it's going to take some time. But what I already did is I basically, to save some time, I've already did a run. So everything was same. Once I click on finish, what's going to happen is it's basically going to try that data set with different algorithms and with different hyperparameters, right? So as you can see, there are multiple runs which happens in parallel, right? And it basically gives me the accuracy over here, right? Any point of time, if I want to go and look into details of a particular run, I can actually go and do that. So you can see this is the algorithm which has been taken. It gives me the accuracy. If I want to look for other metrics, I can actually go and do that. Okay. And then I can actually look into the visualization for the more details about the run and the model, as you can see over here. So if you're working in the data science world, you already know that what is the meaning of precision recall, calibration curve, lift curve. So everything is over here for all the models and all the hyperparameters that have been selected to reach that accuracy. All this information is provided over here, right? You don't have to be manually keeping note of any of these, right? So if I go into the explanation, it basically try to give you some explanation as well. And what that explanation means is it basically try to explain that, you know, what features are directly impacting the model, right? Which is sometimes pretty hard to figure it out, that what are the features are most important when we are training the model. But with this feature, it's basically going to help you to do that. It's going to take some time, so probably I'll just leave it for now and go into the log. So you can look onto the logs. If you found that there's some problem, there's some error, you will get all the logs of your execution over here, right? And then obviously you have the outputs, which is your YAML file, your model in a pickle file, which you can see over here, your scoring file. So all this information will available, right? Now, if I go into the run detail again, in the details, it basically tells me the best model as well. So automatically it suggested me that this particular model or algorithm with accuracy of 91% probably is the best suit. Now, if I'm okay, I can go ahead and go with this model, and then I can select that, and then I can say deploy. So once I'm going to deploy, I can actually go ahead and deploy this model from the UI itself. So now it's going to take some time to deploy this model, but I'll come back over here. So as you can see, I can just go ahead and provide the name. So I'm going to say this is my test model. And then it basically asking me where you want to deploy, either in AKS, where can I have a multiple node cluster, or maybe Azure Container Instance. And once I say that's enough, just go ahead and deploy. It will start deploying my model. So that's all it's going to take you to, deploy your model over here. Now, while it's doing it, I'll just go back over here and go to that run again. Okay. Now, we also have something called data guardrails, which basically look into the data, and if any class balancing is required to do on that particular data, it automatically is going to do it for you. If there is any missing feature values imputation is required, it automatically is going to do you. So what that means is the machine learning will automatically do all this for you, and it basically going to provide you that information. So for example, validation split, right? As you can see, it automatically does the validation split handling for you. So how much is going to go for the training, how much is going to go for the validation, everything over here. So now you can see for this particular model, it basically taking the 90% of data for the training and 10% data for the test, right? And then we already have the models. You will have all the logs, right? And as I mentioned, once you deploy, your model is basically going to be deployed over here, and you can actually say just go ahead and deploy, and it's just going to deploy and gives you the endpoint over here, right? So that easy it for you, to build the machine learning model, rather than wasting a time yourself writing a code, or maybe through the visual interface, you just keep changing the different algorithms and resetting the different features, or maybe changing the hyperparameters multiple times. With automatic machine learning, you can actually go ahead and let the machine learning do it for you parallelly. And then once the report comes out, you can actually go ahead and look into that and just go ahead and deploy your model with the ease. All right, so I think with that, let me just go back into the presentation and hand it over to Ian for onto the. He's gonna walk us through to the next.
Okay, from now then, yeah, it's my turn again. So I want to summarize what we have introduced on over AIs. And then previously, then I mentioned AIFs and agent part and knowledge mining part. And then Sudhir also mentioned great insight on AutoML, including general machine learning stuff. So hopefully then you get some insight on how to implement AIs. So today then I wanted to mention that please think about some total perspective on AI stuffs. Microsoft Azure now supports mainly three different perspectives of AIs. One is pre-built AIs, and the second one is custom AIs, which can be customized from previous AIs, existing previous AIs. And the third one is your own machine learning, for example, using AutoML or using machine learning services, as Sudhir mentioned. Usually then it depends on what you would like to solve, but according to some general statistics or research, and then previous models are introduced as to solve lots of problems, more about even about 80%. So it means that lots of problems actually can be solved using previous AIs for human-like capabilities in apps. So then participants can think about how to leverage into previous AIs, but I really understand and I really expect your great idea, but please do not limit just to leveraging previous AIs. If you have great pre-knowledges on AIs, and then if you can develop more great AIs using your own algorithms, using all your own or more data, and then you can also focus on 20%. But I think that all the participants may have different backgrounds on AIs and machine learnings. So then it is still good to focus on existing previous AIs or leveraging custom AIs, which is part of 80% to solve of main lots of problems. Yeah, this I can say the previous AI is not just magic, but however, that really helps your problems to think about easily, and then it provides you to more think about your own real problems. Previous AIs can solve some simple problems, and then your own custom AIs models or machine learning algorithms can solve remaining 20% to focus more. Microsoft AI really wants to increase your productivity to solve your real world problems. And then please think about the production side. Previous AI already provides lots of existing APIs, and which is very scalable. But however, then to really implement into real production architecture, then it just using AI would not be sufficient. So it is not just a rocket. So please think about how it can be used for production side. Also, then please think about how integration, such integration would impact more people to empower every person. And also then I want to mention to convert my thoughts into for your perspective to how to build your hackathon project. This would be more on phase 2, but for your consideration on architecture, and then please think about that which APIs or leverages or functionalities are provided from Azure. Please do some research, and then you can also think about lots of existing AI APIs, or then you can use machine learning to solve some programs, and then you can build your own architecture. And also then it is targeting for page 2, but it is still a good idea to think about how to collaborate with your team members with Git, GitHub, or Azure DevOps, or and so on. And also then the tool chain might be different to your team members. So then I think you are already joined in Teams channel, but if you have not organized your team, and then if you want to solve great problems with team members, and then please discuss or including tool chains. Because for example, that I saw lots of cases that there are 3 AI engineers, but one AI engineer is only interested in Keras, and the second AI engineer is only interested in TensorFlow, or third AI engineer is interested in implementing using PyTorch, and then their gap minimized. Although then, so Microsoft now also tries to solve such collaboration into Onyx solution. But if you are not familiar with Onyx, then please think about how to better collaborate each other. And also then, as I mentioned several times, then please think about some production perspective, which is one of key parts to consider your great idea with judgment. And then, and final one is that Azure is not just targeting for C# language. For example, then C# is, although C# is still one of great Microsoft driving languages, but also then now Azure AI supports lots of existing programming languages like JavaScript or Python or even any other languages. So this site is just I easily integrated with previous APIs using React, using JavaScript technologies. So you can also maximize your own productivity on phase 2 using your preferred tool chains, but please think about how to collaborate with your team members. And finally, then it is introduced in on MS Azure AI Hackathon website, but please see there are lots of resources, plentiful resources on to understand Microsoft AI solutions with production perspective. So please see this Azure Hackathon hackbook of lots of documents or even some videos would be very useful, I think. So that's all what I want to say.